Hello, everyone. This is Ashley Childress with the Statistics Division of ASQ. I would like to welcome you and thank you for joining us. Our speaker today is Victor Prybutok, who will be speaking on survey design and analysis. Victor R. Prybutok, PhD, CQE, CQA, CMQ, OE, PSTAT, is a Regents Professor of Decision Sciences in the Information Technology and Decision Sciences Department and Vice Provost of the Toulouse Graduate School at the University of North Texas. He has authored over 180 journal articles and more than 200 conference presentations in information systems measurement, quality control, risk assessment, and applied statistics. All phones and microphones other than the presenters have been muted. If you have any questions or comments during the webinar, please use the questions interface in the GoToWebinar control panel. Time willing, these will be answered at the end of the presentation. So at this time, I'm going to hand things over to you, Victor. Thank you so much for presenting with us.
Well, Ashley, thank you for the introduction, and I want to thank all of you for attending. I want to let you know that I have been a professor and a member of ASQ, American Society for Quality, for over 30 years. And in that regard, I have great concern that all of you get the most out of this webinar. With that, I've thought about both the academic side of it and the rigor that is required, as well as what practitioner needs. I've consulted and worked as a practitioner in industry, and so I'm familiar with the use of these tools, both from a practical sense as well as from an academic sense. Today's webinar is looking at survey design and development, the utilization of survey methods for collecting data from customers in the broadest sense, users, internal customers, etc. And I want to try to give you a background for how you develop and use survey data, analyze that to gain information that is useful for your goals. So let's get started in terms of what we're trying to do here. And if we look at the agenda, I want to start with a research model. Those of you who are practitioners may wonder why I mention a research model. I'll explain in more detail, but I think it's critical that you anchor your surveys in established literature. Much of that literature could be practitioner focused, but it'll have a certain rigor that it brings to the type of questions you ask. I'll talk about survey research, questionnaire design, survey biases, construct development and measurement, and then the analysis of the data that includes factor analysis, reliability, and then the use of that data to build models and potentially predict what you're after using regression and structural equation modeling. So let's talk about the need for a research model. The research model, you know, people think of research in terms of some scientists working in a lab, but in terms of survey development, we often start with practitioner insight, which is they have a construct that they would like to measure, something like service quality, and they would like to use that to predict customer intention. It could be something like customer loyalty, intention to make a purchase, and there's many other variables that you might hypothesize influence those constructs. So I'm just mentioning the simplest case where we have a construct A trying to predict a construct B. I use the term construct because we shouldn't be simply asking a single question about satisfaction with service, nor should we be asking a simple question, one single question about loyalty, unless you're doing open-ended surveys where you're actually collecting qualitative information and analyzing that. And while I'll mention that briefly, it isn't the focus of what we're doing here, because for many companies, while qualitative work is important, it is a precursor to the ongoing data collection that they do using quantitative survey methods. So a construct is basically a concept that one wants to measure, a concept such as service quality. And you can theorize what service quality is and ask several questions about it. There are many measures of service quality that exist in the literature, but one of the most widely accepted was developed by Parasurman, Zementhal, and Berry. And that one focuses in on 5 dimensions that make service quality: tangibles, reliability, responsiveness, assurance, and empathy. So I'm taking a more simplistic view, at least for purposes of the research model here, and saying we're going to ask some overall service quality measures, and those exist as well. And there's usually about 5 questions that should interrelate to give you an idea of the overall impression of service quality. And those questions are often called items, and those items, if they work properly, make up that construct and allow you to predict the likelihood of a customer making a purchase or continuing to be loyal to your organization, and or potentially the likelihood that they will switch to another organization or provider. So we talk about that in terms of developing questions, designing a survey. We have independent and dependent variables where one construct, service quality, is trying to predict loyalty, the dependent variable. So we have to go from conceptualization to operationalization, which is what is it that we ask. And this is often best done by looking in the literature to see what has been done. So for example, if you wanted to develop a survey instrument to measure fast food service quality, Ching and Prybutok published a paper in Quality Management Journal. We used the ServQual instrument, but we didn't presume it automatically transferred to this new construct. What we did instead was contextualize all the questions to fast food, administer the survey, and revalidate in the new context. All right, so I've introduced a tiny bit about survey research, and I know some of you may have very strong backgrounds in survey research, while others of you, this is an overview that'll introduce the topic to you. Even for those of you with strong backgrounds, I'm hoping that what I'm presenting here gives you some insights that you hadn't previously thought of and some new ways to approach survey design and development. For those of you who are less experienced, you need to recognize that in 1 hour, this overview is an introduction that you will need to follow up on in order to be able to make more effective use of this if it is your intent to develop, administer surveys, collect data, analyze it, and use it for purposes of bettering your organization. So the first thing we're going to talk about is what is it that we're doing with a survey. And there's many different types of surveys, but the most common is to survey individuals. And we do this because we want to know something about a trait, an attitude, a belief, a likely behavior. And this allows us to collect data both quickly, ongoingly, as well as across large regions of the world. We can actually conduct surveys on the web and via mobile devices that would reach people all across the world. Now, there are issues with reaching those individuals that we can talk about later as we continue. These surveys are both convenient and unobtrusive and economical. Some are extremely short. Mostly when we're developing surveys initially, they tend to be longer and then be reduced over time as we better develop the relationships and understand what we're measuring better. But initially, some level of survey development is required to validate the items we're asking and to confirm that they behave as intended and relate to the measure we want. So for example, if you have a well-established relationship between service quality and customer loyalty, we can ongoingly measure only service quality and intermittently reconfirm that that relationship is as strong as we thought. It's actually somewhat important to reconfirm occasionally because over time things have a way of changing. Time being, many years, but we don't want to necessarily just conduct a survey for decades without having re-examined the assumptions in its utilization. The other thing about surveys is that we can collect large amounts of data. If we collect large amounts of data, you can actually look at subgroups within that population so that we can then take a look at how one population, one segment of a population behaves versus another. So for example, in Quality Management Journal some years ago, actually 2017, this one's more recent, Ching, Boomi, George, and Prybutok, we published a paper looking at the moderating effect of gender in urgent care service quality. This wouldn't have been possible if we hadn't collected demographics from the individuals that allowed us to collect gender, education, age. So these are the kinds of things that often go along with a survey, even though what we wanted to know was the precursors of urgent care service satisfaction, and then ultimately whether individuals were likely to use urgent care versus some other kind of service. So there are some disadvantages to survey research. One of those disadvantages is the possibility that the measure you're taking isn't truly the measure you want, which is why some of this pre-work that I'm talking about in terms of looking in the literature and validating that your items work as they do is necessary, and I'll talk more about that as we go on. In addition, there's the possibility that you have distinct sampling biases. For example, I mentioned that you can conduct surveys all around the world electronically using internet-based surveys or mobile-based surveys. But when you do that, there's a clear digital divide. There's people you won't be able to collect data from because they don't have access to mobile devices and computers, or they're not sophisticated about using them. So one population that you may not be able to survey is the aged, because while some of them are computer sophisticated and have access, there's a segment that isn't, and therefore you're not going to get true representation. This non-response bias becomes critical in some instances, and in others it's less critical. It depends on whether the sample you have is sufficient for purposes of making the kinds of predictions you want. When it's not, it becomes more problematic. All right, so we can talk about what kind of instrument we have. The term instrument is used to refer to a survey instrument or the questionnaire. And then we talk about questions on the instrument being items. Some of you who have more mathematical training may think of it as a variable, but variable is more general terminology and could be a construct or a question, etc., whereas this terminology is generally more specific to surveys, though the terminology will vary with a particular industry, and so you may have a slightly different terminology that you use based on the type of research you do, the company that you're in. One of the things I mentioned is you can have unstructured responses. You can actually collect verbal responses, or you can ask people to fill in boxes. The problem with unstructured responses is that qualitative analysis is relatively tedious, and there's a certain level of interpretation that we hope we can go around when we developed more structured response formats. However, most of the surveys that I developed that are structured have a qualitative front end related to developing the original constructs and validating those. And so there is this pre-work that I do even before I test the survey to validate that things are measuring what they're intended in the way they're intended to measure. There's specific terms for that we'll get to. Self-monitoring is a critical issue with many surveys if you're going to give it to many people. So we talk about self-monitored mail surveys. You know, it's been decades since I've actually gotten a survey in the mail, but at one time it was quite common. And people used to give you the opportunity to get results or get a drawing, but you had to fill out paper surveys. There are times when that's actually the best way to administer a survey. Kind of a funny example, but a well-utilized sample was a couple where I presented at dinner meetings, like the dinner meeting of the Dallas section of the American Society of Quality, which I'm a member of. And so I presented at that about the value of education and certifications in terms of career progression, or lifetime earnings, etc. But while I was there, in exchange for me giving this presentation, I was allowed to conduct a survey of all the attendees. And so I had a few hundred dinner meeting attendees who filled out a survey about the Malcolm Baldrige National Quality Award. And we then published that in the Journal of Computer Information Systems because we had people from many organizations. And so we can talk about, it would be nice to go back and do that same survey at a later time, hence a longitudinal survey. Now, usually longitudinal surveys are the same individuals over time in the classic sense, like we would take a look at twins who are separated at birth and cover those. The longest longitudinal social study was conducted many years ago to look at twins and how environment affected them versus genetics. So that's what people traditionally think of. But in an organization, we could be talking in the sense of longitudinal, that we've taken the survey at 0.1 in time and 0.2 in time, 0.3 in time. So I talked about administering a survey to a group and then online. Now, there are times when you do both, that we actually make surveys available both online and in paper. And that usually works quite well for capturing people that don't have computer access, providing you know that there's no systematic difference between the kinds of answers you get on those two forms. We actually conducted some studies, and we found that those in the US will traditionally answer both a paper and online survey in the same way. But in the case of China, there is the desire to satisfy the surveyor by respondents, and that increases when that surveyor is in front of them, or even someone else who is handing out the surveys for the individual. So individuals who are responding want to satisfy or provide the type of response you might like to hear. And then we found statistically significant differences between paper versus web-based surveys in China, but not in the US. And that was published in several journals depending on the exact type of surveys we were doing. But the point is, it's critical to understand the method of delivery and how it influences your respondents and the cultural issues that are involved in doing that. When we go talk about culture, there's many different things that could affect respondents. Like, for example, I talked about looking at segments of populations. We found out that in urgent care, gender made a difference. We've also found that in other cases. In other cases, age makes a difference. These are things that are important for you to understand. They're not always critical initially, but as you become more sophisticated in segmenting the market and looking at subgroups of your users and your customers, it becomes more critical to understand better how each might respond and what is the appropriate way to both sample and the kind of data that you need. So I mentioned that a survey design and development is both an art as well as a science. And there's a great deal of science involved in survey methods, delivery, and analysis. That said, the art is that practitioners know their environment well, and it is important for the surveyor to understand the environment and be able to contextualize specifically to that environment. Or the survey that worked well in several other applications may not transfer well because it hasn't been validated in the context in which it's being delivered. You can work with practitioners who have great insight to try to mitigate that, but that is why I talk about the art, because sometimes there are nuances to this that would escape the researcher or the survey design expert. We can talk about response format. We talked about collecting demographics, gender, age, income. You know, we could think of income as being a continuous scale where somebody could have zero income all the way up to some astronomical number, but we normally put a range on that. So how do we collect data will affect the analysis. We could have dichotomous variables, which are yes and no, agree, disagree. I generally don't ask whether people agree or disagree, but rather tend to ask strength of agreement, because then I get a 5-point Likert scale for that item. I think it has advantages in the analysis. But that said, there are times when you cannot avoid asking that kind of question, or you would want to do it in addition. So in addition to asking likelihood of making a purchase, you may ask intent to purchase. You intend or don't. You may ask whether someone made a purchase or didn't, whether someone visited, like in the urgent care. We wanted to deal with recall issues, so we wanted to know that they visited the urgent care center more recently rather than trying to recall an experience a long time ago. That's more like a qualifier question. We also ask nominal questions. For example, we could ask what industry type, and we can divide that up into a variety of different ones, but manufacturing and service, retail. We also ask ordinal data so that we can look at education, and we can go high school, some college, etc. More frequently, for purposes of constructs, we're asking Likert scale type data where we have either a 4-point scale. Some people are adherents of even numbers. I tend to use odd. I have a rationale for that, but it's complex in terms of the analysis. But like a 5 to 7-point scale, even 4 to 10 exists out there. And on that, one anchor would be strongly disagree and the other would be strongly agree, and sometimes you see midpoints with labels as well as other labels depending on the design of the survey. It's important to recognize that there's a lot of nuances to asking questions or you get meaningless responses. So they have to be simple, they have to be clear, they have to be active voice. We want to avoid jargon. I frequently see new surveyors asking questions in the context that they well understand, thinking others understand that as well, and that's not necessarily the case. So one way to make sure people understand is to define terms or to use more general terminology, at least with regard to the question, even if you have a scenario that establishes what they're responding in regard to. Generally, we would like positively worded questions, and we don't want what's called double-barreled or and. So we don't want to ask about whether the service was both courteous and timely. Those are two separate questions. And one can be courteous without being timely, or vice versa. So it's important to separate questions, not think that the and is, every time you put an and, more than likely you have two distinct questions that should have been asked. Also avoid something that's too general or too open-ended or presumptuous. Question sequencing is another issue. A classic example is to ask something about work environment and then to ask people if they find flexible hours are conducive to a good work environment. Then to subsequently ask what factors people consider important in a good work environment. You're likely to get flexible hours as a response from many of the respondents. If you reverse those questions, you greatly decrease the likelihood that flexible hours will appear. So you need to actually think about the logical sequence of questions and move sequentially through them. There's many guidelines for doing that. Some say from least to most sensitive, from more general to more specific, from factual to attitudinal. These are just general rules of thumb, but in specific situations, you may opt to do something different because in that particular context, it works better to do it in a different manner. It's also important to do one topic at a time, and for example, one construct, and then transition to the new construct. You might, in surveys many years ago, people used to actually think about randomizing every single item. But the cognitive load on the respondents is considerable if every question has to be thought about separately without looking at a cluster of questions or a small subgroup of questions that ask the same thing. So if we go back to like a construct and we talk about, let's say, service quality being made of 5 dimensions, that's not 5 questions. Each of those dimensions, such as tangibles, has like 4 to 5 items that you have to ask, questions that you have to ask, because you need to establish that the measure is consistent and reliable. And while one item could be off in one person's perception, on average, those questions should behave about the same way. So if we talk about tangibles and service quality, and we talk about fast food, we're typically talking about the cleanliness of the table, the appearance of the individuals, and those are separate questions that you're asking that should correlate to the tangible environment. You wouldn't want to mix tangible questions in with reliability questions, but rather ask each set separately. We talked about developing a survey from the literature or from prior practice, and then it's more appropriate to then have experts review it for levels of validity, and ultimately you want to test it via a pre-test. These are parts of survey design I'll go into a little more as we continue through the presentation. We generally also want to assure people that we're going to keep their individual responses confidential. So even if you're going to collect individuals' names and addresses for purposes of giving them results, which is not an uncommon thing to do if people are generating time and energy to give you responses, and therefore they might have that request. What you can do is have them complete the survey and then be careful to state that they're exiting to another survey that will keep those responses with names and information to send them reports separate. You also want to keep a survey as short as possible to achieve the goals. Now, there's a balance between short and measurement issues. We can't necessarily ask only one question to measure a construct because we won't be able to establish reliability. But if we ask too many constructs because we're not sure about the relationships we're studying, it's best to do that only at the development stage of a survey, because respondent fatigue will affect the way in which people respond to your questions and ultimately the reliability and validity of the survey data. So it's important to keep surveys as short as possible to achieve your goals, and in recognition of the individuals who are responding, both to be courteous about their time and energy, but also because not all respondents would take the time to answer longer surveys, which is why we have other ways to collect data. Potentially we have paid respondents that we use on longer surveys, and then shorter ones with end customers. If you have high-level professionals who are invested in generating the data for purposes of assessing an organization, you might well be able to use a much longer survey than you would with customers who, for example, visit the automobile dealership for service. When we do surveys with different organizations, we frequently agree to give the organization a report that has value to them, and we make sure that we talk to them about what has value for them in the conduct of the survey and what kind of report would be valuable. And if we have to add some additional constructs, we will do so in order to satisfy the organization so that we can both give the type of data that they need as well as collect the type of data we need to conduct our research or develop the model that we're trying to develop. So we talked about sampling correctly, and we talked about the possibility of not sampling correctly by virtue of having subgroups that are systematically not responding. That's usually classified as non-response bias. So what we need to be sure of is that the people who responded to our survey, the sample, are relatively representative of the population to which we would like to make inferences. Non-response bias is when there's a systematic characteristic that precludes an entire population. So I mentioned, for example, you'd have a difficult time if you administer surveys only on the internet and on mobile devices, and it would be even more so if it was only mobile device based, with the aged. And so we need to be sure that we understand that our results won't necessarily extend to that population unless you're going to survey them in another way to confirm that their responses are consistent with the other methods by which we've delivered surveys. There's also the possibility that that non-respondent group simply doesn't respond because they choose not to participate, but that they have some common characteristic. Ways to mitigate that are to look at the respondents and then examine the data of respondents. But based on literature, we believe that the last 10% of respondents actually share some common characteristics with the non-respondents versus the first 90%. Armstrong and Overton published this, and later several other people have examined it. And so what we frequently do is we take the first 90% of our respondents and look at the last 10% as a separate group, and we analyze them in terms of their demographics to see if there's some systematic difference, such as there's a large gender difference between one group and the other, or their responses to the constructs. So we can do that to help mitigate that we don't have a non-response bias. Sampling biases are going to result in potential non-response bias, but can also have other complications. So for example, we frequently conduct sample surveys here at the University of North Texas with our students. Now, our students are indicative of many students across the United States. We have a large university with 37,000, 38,000 students, and undergraduates here have a lot in common with undergraduates around the United States. And for many things that we would study, such as mobile phones or fast food, that might be true. But if we were looking at particular aspects of fast food, it's likely that around many regions of the United States, individuals wouldn't necessarily want a burger with jalapenos on it. Yet the Texas burger is somewhat common in fast food restaurants in our area. So you need to be conscious of systematic differences and not overly generalize from one sample to another, or test the transferability of your survey to another region or location. We talked about satisficing, and this is when there's an identification of the individual with the desire to portray themselves in a socially desirable manner, and therefore they may respond more positively than they would otherwise. This can be because they want to please the reviewer, or it can be simply that they don't want to think of themselves in a more negative context. There's also the possibility of recall bias. Why I mentioned that when we conducted the urgent care study, we asked specifically how recently they had visited, and we removed individuals that didn't visit the urgent care center within a recent period. We actually tried to do it at the beginning of fall so that most students would have to go into at least their urgent care center for their physical before school started. There's also something called common method bias. A simplistic example of that is that somebody rifles down and answers almost the same answer to every item, so that the dependent and independent variable aren't differentiating well. One way to look for that is to look for common patterns, and likely if there's a distinct pattern, like somebody's answered all A's, that's not a valid survey. But there's other tests for it, like we can look at something like the Harmon test, which runs an exploratory factor analysis on all the items of the survey, and then you determine that the first factor doesn't account for more than 50% of the variance, and that there's more than one factor in the survey. The marker test is even better, but beyond the scope of what we can cover right here. So we've talked a little about construct development and measurement, where you have to conceptualize what it is that people are doing. You have to identify the items the questions that will measure that construct, and you have to think about them in terms of, at least in structural equation modeling, it would matter whether they're viewed as reflective or formative, where a reflective measure is something you've asked about that indicates an association with the construct, whereas a formative measure is a measure where you've actually asked specific characteristics of the construct and you've fully defined it with the questions you've asked. Measurement levels, we talked about nominal, ordinal, interval, ratio, and I tend to ask those of demographics and use Likert type scales for items that are questions on the survey that I can use to measure a construct, because I'm trying to develop a scale where I can then use that by averaging the items to get a measure and use it in a regression model or potentially in a structural equation model. So we have to worry about things like validity when we develop a construct. How well does this measure relate to the theoretical construct? How well do the items that we've asked, the questions, link to the construct itself? And how well does that construct correlate with the things that we expect it to, but still differentiate sufficiently to be an independent measure? So we talk about scale reliability, and that has to do with, again, having a consistent measure like service quality, which when we improve service quality, presumably relates to an improvement in customer loyalty in the particular model we might hypothesize. We talk about inter-rater reliability in surveys, which is that two individuals have the same level of perception, and two or more, and that as we change performance in a particular area, we can measure those items and then use those items to guide continuous improvement, because the usual use of a survey is to maintain or improve service over time. If we give the same survey without any changes, we should get much the same results. So we talk about test, retest reliability. At times it's convenient to take really large samples, split the survey in half, use half for development and of the model, item cleaning, construct validity, and then ultimately model fit, and then use the second half as an independent random sample to validate and confirm the model. Reliability, there's several measures of reliability. The two most common that we use, Cronbach's alpha, which is the average correlation among items. It's a simple average for two items. And composite reliability, which looks at an average loading on a construct. They're slightly different, but Cronbach's alpha you'll get out of most stat packages like SPSS, Minitab. Composite reliability you get out of structural equation modeling packages such as Lizarol, Amos, covariance-based, or regression-based like partial least squares. So it's always useful when we first develop a set of questions in a survey, aside from proofreading it and having practitioners go through it, to ask other experts to look at the construct name and see if they believe the items that you've asked relate to that construct and measure the entirety of the domain. So you're looking for both face and content validity confirmation from this group of experts that will review your survey. These can be other professionals in your own area, or they can be people who are willing to assist you because they're colleagues and experts in the area. We also look at convergent validity, which is how well does this measure what it's intended and relate to other constructs in the way that it's intended, versus discriminant validity, where we want to have the correlation between two constructs be at least sufficiently low that we know each measure in the construct is independent. One way to do that is to look at the individual items using factor analysis. So we can talk about both exploratory factor analysis and confirmatory, and there's many ways in which this is done. One way is to put the items into a package like SPSS. So we conduct our survey electronically, we download the responses, we take the items that are related to the constructs, not the demographics, we run it through factor analysis. We did that initially for purposes of establishing common method bias, but now we're doing it again and we're taking the dependent variables and we're looking at those separately. And what we would like is, if we have a construct A, the lower right you see the cross loadings table, we would like construct A to have every item, lambda is the loading, to have a loading on factor A that is high. Factor A would have some name based on literature or by reviewing the items and developing a naming convention for that factor. This could be in service quality the tangibles dimension, for example. We would like that lambda, that loading, to be high, higher than 0.5, preferably as high or higher than 0.7, and low on all the other factors so that we know that item A1 discriminates by virtue of measuring A and not B and C. So what is lower? Well, some people will say at least less than 0.5, and some people would say preferably less than 0.3. So if that happens, and all the items on factor A load on A cleanly and not on B and C, and similarly those on B, we have confirmed that the loadings load as theorized and that we've properly contextualized our survey from one context to another. There's other ways to do this, but this is at least one way to confirm a level of discriminant validity. We also look at the average variance extracted, which is, if we look at the loadings of the items on a construct, we essentially want to know something about their average loadings, a weighted average, and how that compares to the correlation among constructs. If we take the square root of the average variance extracted, we can put it into a matrix. This is actually automated and provided in most structural equation modeling packages, but can be obtained other ways if you're not using one. And so we can take the average variance extracted, put it along the main diagonal element. So we have, for example, factor A has average variance extracted. The square root of that is y. That value should be higher than going down column A than all of the correlations, the correlation between B and A, C and A, etc., so that we know that we're discriminating properly with those items, measuring A and not loading on other factors. Yet another way to look at discriminant validity. So why do we want to do this? We want to do this because ultimately we need to develop clean measures that measure what they're intended to measure and that allow us to predict. So if it's customer loyalty that I wish to predict, then I would say use service quality, and I would have 5 dimensions, but I could just, for example, use an overall service quality measure where I have 5 or 6 questions, and such measures exist, that measure overall service quality. And in that case, I want to average the service quality items. I want to average the items I asked about loyalty. And I want to look at a simple regression to show that there is a statistically significant relationship between service quality and loyalty. Now, that alone is not enough, but that's the point of simple regression. Now, multiple regression, if I measured service quality using 5 dimensions, I would separately average each dimension because they are independent factors, and then I would use all 5 of those to predict customer loyalty. There's also logistic regression, and in logistic regression, our dependent variable is a yes, no, a 1 or a 0. So someone either made a purchase or didn't, and we conducted surveys of people who made purchases and didn't. I think it's also particularly useful when you use that kind of measure to have another measure that's a scale-based measure so that you have some flexibility in your analysis rather than just asking if they made a purchase or didn't. So we talked about simple regression, and in this case we might want to look at, as satisfaction goes up, loyalty should go up, a positive relationship, the lower right. Alternatively, we might have a negative relationship that we're studying, and that would be as satisfaction goes up, likelihood of switching to another mobile phone provider should go down. So that would be negative. Simple regression looks at the fit of points about a line and judges the deviations from the fit compared to the random variation in the data. That's a statistical test that's conducted using an ANOVA on the model, the F test. But in fact, in simple regression, the F test on the model is exactly the same as the T test on the slope. So we need not look at both, although it's not uncommon to look at both simply because of the way this material is traditionally taught. All right, so if we take a look at running this in Excel, and it can be run in Excel, you can run a simple regression, and we can look at something simple like the price of a vehicle versus the mileage. And for a given type of vehicle, and in a small range of years, we would expect a reasonably good relationship. If we varied the type of vehicle greatly, you know, like a Ford Fiesta and a Mercedes, then that's going to drown out the mileage versus price because of the drastic differences in price of the kinds of models. But if we have, so again, it comes down to understanding your data, understanding your sample, and being, so in this case, we in fact have one kind of vehicle, and we're looking at over a small group of years, and we're looking at price versus mileage. And we would expect as mileage goes up, price goes down. Even if that is statistically significant, though, we have to think about whether or not we have a good relationship in other ways. So if we look at the next data set that's provided, if we look at this, we see that on the Excel output, we can do the F-test on the model. We can see regression F-test is 794.5, and that is statistically significant because the significance of the F, or the p-value, is essentially 0. The t-test should give us the same number in simple regression, and in fact it does give us exactly the same number. So if you look at the p-value for the t-test on the coefficient for mileage, the B1, which is negative 0.107, that is the coefficient. We conduct the t, we get negative 28.2, and the p-value is exactly the same as the f, because in simple regression this is in fact the same test. The t-squared will equal the f-value. And so again, we have a statistically significant relationship. But have we explained enough of the variation in price to have a practically significant model? So at that point, we would go up and look at the regression statistics in the upper left corner of the Excel output. You see the R-square value is 0.75. 75% of the variation in price is explained by the mileage. So we have certain assumptions in simple regression that the residuals have to be normally distributed with a mean of 0 and uncorrelated. And we can confirm that with a histogram and scatter plots. Multiple regression is when we have more than one independent variable. So now we've taken the same data set and we've expanded it to include, even within a small group of years, the age of the vehicle, whether it's 1 year old, 2 years old, the body type, let's say sedan or coupe, and we want to see whether or not we get a better model. Now, we already know we have a reasonable model in terms of statistical significance, but you may wonder if you can improve your R-square by virtue of adding variables, which is why we ask more constructs on surveys. This is a simple example that most of you can relate to, but it is why we don't simply ask service quality. So if we look at the multiple regression output, we can see again that the F on the model is statistically significant. If we look at the F calculated, it's 385. The p-value is essentially 0, 10 to the minus 94. We look at each individual variable. We can look at the t-values for those and the p-value associated. We see they're all statistically significant because the p-values are all less than 0.05, so they're all significant at the 5% level. And the R-square in the model in the upper left corner has improved. It's gone from that 0.75 to 0.82. We've explained 82% of the variation. And in many applications, in manufacturing or with money, we're dealing with large amounts of money for small changes. So this small improvement is quite important to us. We can also test for interactions. That's done by multiplying one variable by the other. If we have non-parallel lines, such as the interaction where the two lines cross, we have a statistically significant interaction. If we have parallel lines, they're not significant. So in this problem, we're going to test for an interaction by looking for mileage times body type. You can plot that just to get a sense, and you can see that the plot looks nearly parallel, but not exactly. So depending, this may be statistically significant. So we can look at the coefficient 0.00652 and see if it's statistically significant. Turns out in this model it's not. I didn't present it for lack of time. Logistic regression or discriminant analysis looks at groupings. So we're trying to determine whether somebody's going to make a purchase or not make a purchase, whether somebody's going to switch providers or not switch. Again, I think it's generally better to ask things about intention with 5 items, but there are times when this is the only kind of data you can collect. And then you have a logistic regression model where you can run the betas like you did in multiple regression, judge their statistical significance, and look at the odds ratios. I'm going to move through this so we can at least mention structural equation modeling. Many times when we conduct surveys, we are building a structural model where we have multiple independent variables predicting the dependent variable, and then we have other independent variables predicting a different dependent variable, and then those are collectively going towards yet another layer of dependent variable. So this is a somewhat simple structural equation model, but it's one that would be more difficult to test using regression. You'd have to do path models than in structural equation modeling. And in structural equation modeling, we're largely doing confirmatory. You have a developed survey, you're trying to confirm theory or practice with regard to these relationships. And we can talk about all of these variables in a variety of different terminology that's specific to structural equation modeling, but it is not all that different than regression. We conduct a measurement model. We conduct a measurement model for purposes of confirming the item's load on constructs as intended, and we conduct a structural model to see if the relationships fit as we would like, and we judge this with a variety of fit indices. There's a great deal of mathematics. I've included these slides for the benefit of those of you who haven't seen this before, so you at least have an initial point of reference. And if we take a look at running this model statistically, we get outputs where we get something like the normed chi-square. We want that to be less than 3, preferably less than 2. I tend to want to use parsimonious measures. We want the AGFI to be greater than 0.9. It's almost all models will have fit measures above 0.9 if they're good models. And so that is what we're looking for. We can do something similar using partial least squares, which is a regression-based method. I want to thank you all for listening for the last 50 minutes and open it up to questions. Ashley will moderate those. And thank you again.
All right, thanks. I will read through some of the questions that have come in. One from earlier in the presentation I'll start with. You mentioned detecting small effects in subgroup analysis. Could you say a little bit about the statistical significance versus practical importance and multiple testing and inflation of the type 1 error alpha?
So first of all, subgroups become important in terms of market segmentation. We've done surveys, for example, where we looked at web presentation, and we found there's a statistically significant effect based on gender. But the question goes to the heart of how many subgroups can I realistically look at? And at some point, I'm doing so many tests that I am, in fact, inflating alpha. That's always the case. That said, one could, if they wanted to do this, although I've never actually observed it being done, create some kind of rigorous test where you calculate an adjusted alpha based on the number of comparisons and require that level of rigor with regard to the overall significance of the model. But usually we go at this not because we want to run many possible tests, but because we suspect some demographic characteristic accounts for an important part of the population, and we want to show that it is statistically different, such as my example with gender.
Okay. Another question, what about surveyors who ask ordinal questions, for example, strength of agreement, and subsequently translate those responses into, say, a 5-point interval scale for the purposes of computing average values of the responses?
So I tend to prefer using Likert items, and I think that if you use ordinal, that's problematic. For example, I'll give you an exact example. Let's say I ask education, and I talk about high school, some college, graduate school. And then I'm looking at, just keep it very simple, I'm looking at using those to predict income. You're assuming that there's a linear relationship between having high school and an associate's degree, between an associate's degree and some college. But that relationship could be quite nonlinear. Income could go up drastically with certain kinds of education, and you would be not accounting for that unless you could figure out the linearizing transformation, and that is something most people can't do. So it's better to use categorical classifications and dummy variable coding schemes for that kind of ordinal question. Thank you.
Okay, I believe we have one more. When you say one construct at a time in a survey, don't you increase the likelihood of respondents recognizing that and answering the related items the same, thus giving an inflated measure of reliability?
Absolutely, that is true. But we have in fact conducted surveys where we randomized all items, and we've conducted surveys where we have the construct separated and we ask items related to that, and we have found that the kind of reliability inflation is less critical than the respondent fatigue and the destruction of data that occurs when we randomize all items. We conducted a survey with almost 7,000 individuals at the United States Veterans Administration who were involved in their IT operations. And that data, while very valuable, was less valuable than it would have been because we made the critical error of randomizing more than we should have.
Okay, I will read one more follow-up question to that response, and then we'll wrap up. But a Likert scale is ordinal since it does not possess the property of distance. It is a measure of value perception. Care to comment?
Yes, so that is actually true, and a statistical purist would tell you that you can't use Likert items, but I'm not using one item. In the way in which, if you sum many Likert items, they do tend to approach some level of normality. So when we have, which is why we tend to want to have just more than 3 items minimum, we increase the likelihood that the response to those 3 items, the sum or the average, behaves with better properties than a single item measure on a Likert scale, which would suffer from the kinds of things, the linearity assumption that is imposed on, that I mentioned in ordinal data. So it's true that there is some substance to what's being asked there, but that is not what's done in current survey methods today, despite the fact that pure statistical background would suggest that that's not the case.
Okay, thank you.
Thank you all
Excellent.
again.
All right, we ask that our attendees complete the short survey at this time available within GoToWebinar. A recording of the webinar will be available within a few days on the division's YouTube channel at youtube.com/ASQStatsDivision. Please be sure to share this webinar and our other archived webinars with friends, coworkers, and colleagues. Also, we encourage you to check out the division's LinkedIn page as well as our events calendar, which can be viewed at asq.org/statistics for the latest news on webinars, conferences, and many other topics. That's all the time we have today. Thanks everyone for joining us, and thank you again, Victor, for presenting with the Statistics Division. Hope everyone has a wonderful afternoon.